Hi, everybody. I'm super excited to be in ZIFCon again, and thank you for attending my talk. We'll go through what happened with the campaign against Snowflake users and Snowflake clients, and from there we'll move to talk about how we do detections for SaaS platforms, some of the challenges over there, and some options to tackle them. I'll start with the most boring slide about who I am. I'm currently the senior director for the research team with Midiga. We are a cloud security company. Prior to that, I spent a little bit over a decade in offensive security. I've built and ran the offensive services for Anheuser-Busch. I also have my own independent thing where I do IRs or offensive activities. Bachelor's degree in information security and master's degree in criminology, because I'm very excited and interested how bad guys think and what makes them do whatever they do. I'm a big believer in the community. I'm part of the organizing team for B-Sites Tel Aviv. I'm also a DEF CON goon for a few years and part of the team with Trace Labs, where we have CTFs where we use OSINT to track down missing people. And when I'm not dealing with technology and computers, I really like making my own beer at home. So that's pretty much about me. Now when we kick it off, that's something I'm trying to coin for about a year now. It symbolizes a paradigm shift where attackers stopped breaking into things. They only log in. And the reason for that is the big growth in using cloud-based technology. And when we say cloud, usually we talk about Azure, GCP, AWS, of course. But within cloud, I also consider the identity providers and also all the SaaS platforms. Basically, all the technology that we consume, but we don't host and we don't really control. And that's big because all of you are probably already familiar with the rise of info stealers. So info stealers are not something new. They've been around for quite a long time. They are extremely cheap a method of initial access. And recently we start seeing them getting more attention and more news. And the reason for that is thanks to the help of AI and LLM, the barrier of being an attacker or a successful attacker, not even a good attacker, is much lower. And it's much easier to buy credentials, buy a session from an info stealer log, rather than building your own phishing kit or buying someone else's phishing kit. So we see a lot of more attacks, most common attacks, and we'll even discuss an APT group attack against one of the biggest industry giants that didn't have any malware or 0 days, only identity. But let's go back to what we're here to talk about Snowflake. So in an essence, I usually say that Snowflake is the next gen database. They hate it when I say it, so I've put something much more official on the deck. Basically, what we call a data warehouse or a data lake, it's a fully managed cloud service that helps you work with storage. The better way to put it, or the cooler way to put it, Cool Warehouse does all the scaling and stuff we're familiar from the cloud, can handle huge amounts of data in a lot of different structures or non-structures, and as long as you pay the cost, you can pretty much do a lot of very good, cool things about it. The point about being the next-gen database is usually used to emphasize the type of data it holds. And because it holds such significant data, it's a prime target or objective for attackers, because we all know that a lot of the more or most sensitive content within organizations will be within databases. Might be encrypted, not encrypted. Usually we know it's not encrypted, but it's still something attackers are interested in. So what happened in this campaign? It happened a little bit over a year ago. The threat actor that was already arrested, indicted, and I think also found guilty, were financially motivated. Not an APT group, not nation state, somebody from their own home that found a way to make a lot of money. They had a lot of victims. They targeted specifically the clients of Snowflake, not Snowflake, the company itself. They spent a few months getting the data, getting inside those instances of Snowflake owned by those clients, getting a lot of the data out there, and then starting with different techniques of ransomware. Some of the more, I would say, highlighted or known victims of this campaign were the Santander Bank, Ticketmaster. All of them were covered in the news, also within Wired and a lot of other articles. And the funny thing, no vulnerability, no zero-day, no exploit, nothing sexy or attractive as we usually know from this type of big campaigns. It was a bunch of either misconfigurations or poor product design, depends on whose side you are and if you want to get sued by Snowflake. But they just leveraged different parts that we'll soon cover. The way that we came to know about it is one of our clients just reached out and said, we got a notice from the FBI that something might be happening in Snowflake, but we have no details to share, which is a very fun start. And then we started asking around, and I spoke with some friends. We reached out to threat intel vendors if anybody knows something related to Snowflake. Everybody had a very small data point that weren't connected. Nobody really knew what happened. Nothing on the news, nothing public on the internet. And then we said, all right, we're going to start digging in. And some of the things that we came across were they had some tools they used to target Snowflake specifically. Some of them were an instance online by Snowflake where you can sort of put the name of a company and get the URL for their instance. So it's very hard for you, very easy for the attacker to map out, for example, a specific company, which instances they have to start targeting those. They also had a way to stage and exfiltrate using built-in Snowflake functionalities that we'll talk about in the detection period. And the identity part was very interesting. You could configure MFA on your Snowflake instance, but you couldn't enforce it. And that's something that we managed to replicate in a lab, that you bring in your own authentication, and then you said, all right, I want everybody to use MFA. They say, cool, use MFA. But if you try to just log in legacy, even if you had the SSO configured, you could just go in without any MFA. And there wasn't any way to enforce it. This was luckily changed since then. And the attackers managed to get logs from info stealers of a lot of different company employees and managed to get inside this platform, logged in, and exfiltrated a lot of very sensitive data from Snowflake. And as we mentioned, because it's a data warehouse or a data lake, depends how you prefer it, they had a lot of data for the clients, which means a lot of more money. And in the end of the day, everything turned into extortion. But just to put it out there, there were few issues that I don't believe are Snowflake specific. I don't think they are the ones to blame. They build their own product, and a lot of other SaaS companies are doing the same thing. Some of the challenges we have is SaaS and identity, because in the end of the day, we as a company, you buy a service from another company. Then you need to configure either your SSO, but you have very limited control. You have no idea to know if you can enforce it or not. In a lot of companies, and I've seen that in multiple red team, that not all of the SaaS platforms have SSO. Or if you want SSO, you need to pay for a higher license tier. So a lot of companies want to save the money and just let employees log in directly. That creates a lot of complications, even for security tooling, to identify when somebody goes to an unauthorized SaaS or doing something they shouldn't do. The second thing is the perimeter kind of changed. We are used to a few years ago where perimeter were the network. We have a lot of tools, a lot of technology to protect the network, to protect the barrier of somebody coming in, and most of the C2s will communicate out so it's easier to control. But now, when we are in the age of work from everywhere or anywhere, the identity became the new perimeter because you can authenticate from everywhere. All the SaaS are available online. It's very hard to limit access to a lot of different SaaS platforms only based on networking rules, and if you don't have a managed client or anything like that, it becomes even harder. And MFA, unfortunately, still missing in a lot of places. If you look at a lot of recent research that was out there, all those successful info stealers campaign, they lack MFA. People are still authenticating without MFA with huge corporations, huge organizations, and it's still something that holds us back. And in some other cases, even if you have MFA configured, but somebody managed to steal your session token, or you have a non-human identity that you cannot enforce MFA on, you kind of bypass that MFA requirement and still get access into it. Specifically in this campaign, part of the issue was the built-in features, meaning what you can do in Snowflake, you can use a command within the data within your database to copy or siphon out your data to storage accounts. So whether it's an S3 bucket or an Azure storage blob, same for GCP. And when something is built into a software, it's much harder to identify a malicious use of it. Because as I mentioned in on-prem, it's, I would say, easier for us to identify malicious activity because we have hashes, we have unsigned software, we have different C2s, network traffic that's anomalous. Within Cloud and SaaS, the only thing that changes is the intention, meaning if you have a detection when somebody copies data into an S3 bucket, it's very hard for defenders to identify if that's one of our IT admins doing a routine backup, or it's a threat actor doing something we don't want him to do, sort of an unplanned backup. And in the end, the monitoring is much harder within SaaS. Log structure is different from different SaaS providers. Logging is even restricted in some cases, and I'm looking at Slack, I'm looking at Salesforce, that if you want those logs, you need to pay a premium. You need to pay for a higher license tier, and you have delays, built-in delays from when the log is generated until it's sent to your aggregation system, and you can trigger your own detections. And then some of them doesn't even offer any security logging. And the reason for that is that a lot of SaaS platforms are not security platforms. They're not even security aware or security concerned. They are here to provide a specific type of a service or a specific type of functionality. And when you go in, they'll say, yeah, we have a security log. We can show you only logins. And then that's it. And as defenders, it's cool to know when somebody logged in something, but I'm interested in knowing what they did once they logged in. That's part of a good detection engineering. And then a lot of companies doesn't even pull those logs that are available due to cost. SIEM are charging you based on ingestion quantities, so you know that if you're going to bring in either Salesforce, Slack, Snowflake, or any other SaaS platform, you need to pay more for your SIEM provider. And the storage and the compute and all of that goes up. And in some other cases, the SecOps teams are not even aware which logs from which SaaS platform they're interested in. And then when they come in, as we mentioned, each one of them have an entirely different structure. And it's very hard to investigate them. And I'll give you a prime example. If you look at Salesforce, they have different log sources for different content. So you have the authentication log that shows you when somebody authenticated, how they authenticated, and which user authenticated. But they also have the activity log, which shows you what somebody did and when, if they downloaded the report, shared it externally, made it public, anything like that. But the thing is, they don't put the username within the activity log. So if you got an alert in your SIEM and one of your analysts look into that, they'll get a unique ID for the user. And if they downloaded the report, also a different unique string for the report itself, meaning that somebody did something somewhere, and that's it. And I'm very confident in guessing that the majority of companies don't give their SecOps administrative access to Salesforce, because that's not a security platform, that's a business platform, and it makes the investigation almost impossible. And then if you go to the login log, you'll see the matching between the username and the unique ID. And then your own security team needs to start building those correlations and doing their own lookup tables of, all right, if somebody logged in, That's the username, that's the unique ID, and then if I have an alert from a different log source, now I need to match that, and all of that incurs additional delay, not mentioning that all the logs within Salesforce, unless you pay a premium for an add-on, are 24 hours delayed, meaning that everything you'll see happened the soonest one day before. And everybody from offensive side knows that 24 hours are a lot of time to either set up your persistency, to act on your objectives, and to carry out anything that you're pretty much interested in. So we already mentioned that SaaS is cloud, and to this day, we have hundreds of thousands of different SaaS platforms. And I know what you're all thinking. We are already familiar with different tools that have SaaS detections. But I'll challenge you that. Check how many of them can actually see actions within those SaaS platforms, and how many of them have detections and capabilities in the non-security ones. So we know GitHub and GitLab, everything that DevOps are using, everything from part of development. We can see CI/CD pipelines, we can see activities across repositories. But when you go to Slack, if you remember the recent Ripple and Deal thing that went down, where a malicious insider did a lot of channel previews to gather information, they downloaded files from Slack. There are almost no, at least that I could find, open source tools or detections that can pick this type of a thing. They can let you know, all right, when somebody passed the IDP, now they logged in into Slack. Now they logged in into Snowflake. And because all of that, we can see a big or huge increase in attacks that involve the cloud. I remember when I was running operations or doing red team assessments, I know when I want to hide, I'll go to the cloud. I'll go to either SaaS, CSPs, because most of the tools offered for defenders are for configurations. We can see CSPM, SSPM, something PM, even with AI, everything is posture. Everything is how well you are configured and not the actual activity within those environments. So I've mentioned another case study about an APT group. So as you probably remember, last year there was the Microsoft report about Midnight Blizzard. And they revealed that the threat actor is part of the SVR, one of the more or the most advanced attack groups that we know out there. And they targeted Microsoft, which are the, one of the biggest cloud service providers, have a very big budget and a very big and advanced security team and very smart people. And the flow of the attack was surprisingly shocking and easy, quote unquote. It started with a simple password spraying, where you get a very long list of users, you get a very long list of passwords you believe are valid, you run that until you get a hit. Once they had a hit, they managed to log in into a test account in a non-production tenant of Microsoft itself. Moving forward, they managed to get access on one of the OAuth applications within that tenant. They used, everything they did was built-in functionalities within Azure. So they managed to get more permissions, to move to a different OAuth app that had permissions on the production tenant of Microsoft itself. When they moved into that tenant, they managed to escalate their privilege, and using a service principal, which is the Azure equivalent for a service account, to get access to Microsoft Production Exchange, which gave them full access to Microsoft executive mailboxes. Everything we see in here and everything that was reported by Microsoft is not groundbreaking unless you think on how simple it is from technology terms. No 0 days, no fancy tooling or C2s or something that was exposed in like a Vault leak or anything like that. It's something that we are all familiar from different pen tests, different red teams, doesn't require any custom tooling, and the majority of the actual exploitation, once they had a foothold, was using the built-in functionalities of Azure, which is yeah, the cloud. And it got them to a point where they had full access to the email boxes of Microsoft executives. And then it takes us to the detection engineering. And detection engineering in general is hard. When you go to cloud, it's even harder. Because we mentioned, we are looking to identify intent. And in order to detect intent, you need to have some kind of a context to know, all right, is it something common? Is it the way the user usually behave or the platform behaves? How do you identify anomalies? Because you probably all remember UEBA, and it worked so well that it disappeared. But we need something similar in a sense, because when you look at activity, you need to always think, am I looking at something one of the employees did? If I'm looking at something a malicious insider is doing, if I'm looking at something a threat actor is doing. And then how do we build those baselines? And how much data we need, and which data is available from which platforms? How we correlate and cross-reference across all of it, because everything is online, everything is behind SSO, hopefully, but I still need to look far back and saying, all right, is this user usually logs into Salesforce or Snowflake? Is it usually the IP, the user agent, or the machine they're coming from? And then when I do see that they are doing that every Sunday, but now they're doing it on a Wednesday, how do I know if it's a good thing or a bad thing? And in the end, we need some kind of a generic logic, because we need to apply it across the board. We need to have it in different departments, different tools. We cannot build the same detection for 100 different platforms. It doesn't make sense. We need something generic enough, but we're still having a very big risk of false positives, which is what SOC teams hates the most. So when we bring all of it together, one way to tackle it is to build in the threat intelligence piece into that. For example, with Snowflake, the companies that were affected already started getting feeds of whether it's IOCs, intent. In that case, it was a specific VPN provider, so you can get online all the IPs and start using that as your first trigger of something bad is going on. And then looking at all the events metadata. So which country they're authenticating from? Is it a common country or not? Is it something we have offices in or people in? Which type of connection is it? Are they coming from Tor? Are they coming from a proxy, from the VPN? Is it the same browser they're usually using? Is it the same operating system? If I know my IT guys are using MacBooks, if they authenticate from a Windows box, that's very weird. And of course, event spike. When an attacker comes in a lot of cases, they want to smash and grab. Once they get access, they don't know where it's going to be terminated, so they'll start downloading or moving things around. And then the type of activity. If I know, for example, from non-human identities, that's very strong, because in a lot of cases, you have API keys for specific departments and purposes. If I have an API key that deploys an application, goes and puts files in a bucket, but now it starts enumerating keys from a vault or going somewhere else, I know it's very weird. If I have somebody that's usually going to Salesforce because they are the CFO, if they log into AWS, that's extremely weird. And then all the sensitivity around different platforms. It's not the same if somebody goes into either Box or Dropbox, or somebody going into either Salesforce, Slack, or any other financial environment. And of course, matching all of that with what we already have from the posture management. All right, if I know something is exposed to the internet, if I know something has a vulnerability and wasn't patched for a long time, all of that comes together to a much stronger confidence, and I can also control the severity of that detection, because SOC gets tens, hundreds of thousands of alerts a day, and they need to prioritize. Building all of that influential points of interest will help them say, all right, this is more severe, this probably have more impact if it's malicious, that's something I want to look into before I'm looking at other stuff. So just as an example on how that would work with this Snowflake campaign is rare IPs logging not through my IDP to a platform. That's already an indication of something odd going on. And then getting the feed from the threat intel, comparing those IPs to the ones I'm already familiar with being problematic in this example, a specific VPN provider that I know the organization is not using, that's another piece of evidence. And then the volume of logins. Somebody trying to log in and maybe doing a password spray or something like that, again, that's the volume and the spike of events. Eventually going and successfully logging into Snowflake, which is probably a crown jewel, sense of the data and the sensitivity we mentioned. And then I'm looking within the platform for specificities. Is that the usual warehouses this entity is querying? Because if it's an IT guy that usually goes to the same warehouse, or a DevOps that goes to the specific warehouse, and now they're going for 100 more, that's an anomaly I want to pick up on. And using the query history log source from Snowflake, which we'll go through in a couple of slides, I can see what usually they're running. So if they're usually doing select X, and now it's entirely different platforms, or copy into, or anything like that, that's additional piece that I'm interested in, and then I can declare the incident. Then the SecOps can trigger the IR process and detect that faster than waiting to hear about it in the news. So talking about a few differences from Snowflake and similar platforms to the database that we already know. In the past, most databases, even when they moved to the cloud, audit logs were kind of local files or transmitted through syslog. Snowflake has their own log sources, and in order to access them, it's the same functionality as using a database. We'll go into that and we'll see those are actually SQL queries that you need to use in order to pull those logs into somewhere else. Locations of databases, they'll either have those logs on-prem on the disk, or even in cloud that will be on the disk or shipped into our SIEM. Snowflake and other ones have a lot of different integrations, so you can pull it either to buckets or data storage, all of that, and from there, you'll either normalize it and pull it to your SIEM or anything like that. And in the end of the day, a lot of different integrations. The thing about SaaS, it's always looking for more integrations, meaning functionalities always improve, always increase, and you can do a lot of more things about it. So going into the details of Snowflake and their own way of their building, so the database is called Snowflake. The schema is called account usage. That's where they host those log sources. And the four, I would say, main log sources that will be interesting for defenders is query history, login history, sessions, and access history. The reason access history has the small asterisk, it's only in the enterprise version. So if you remember, we said a lot of different vendors will limit your capability to defend the product or defend your usage of the product by using license tiers. So now let's break all of them down. The first one will be query history. Note that the latency can be up to 45 minutes. That's something to consider when we build those detections, that we'll always have the delay. This log source will have all the queries ran within Snowflake, so that's very easy for us to identify the anomalies and have good baseline. Some of the columns within it will be the actual query text, the database names, of course, the user, the role, how many results they received. All of that can be very useful for defenders. Login history, as the name suggests, logs all the login attempts. These can be delayed up to 2 hours, and that's something to consider when you'll merge it, of course, with a query history. And here you'll see most of the common fields, so whether when it happened, who did it, where they came from, did they manage to log in, and which additional factors they used. Sessions have a delay of up to 3 hours and have logs of all the sessions within the platform. Doesn't have to be interactive sessions, but that would be very useful because within the Snowflake campaign, the attacker used a specific tool that could be having the signature of the user agent and the type of connection they used. So whether it's a specific application ID and stuff like that. And last, the enterprise history is all of the user activity, even on top of the query history. So that's very useful when you want to see or have the investigation figure out what they did before, what they did afterwards, what they're usually doing. And bringing all of that together, you'll need to mix and match all of those log sources together in the end of the day, considering the different latencies, considering the different content, normalizing that structure based on the requirements of your detection engineering and your own, I would say, IR processes. So a few examples for detections possible within Snowflake that are fairly easier. The first one, as we mentioned, very common initial access today, password spraying. The log you would need would be the login history, and the columns you'll need to pull in will be event timestamp, username, reported client type, and is successful. The reason for that would be not every attempt is a password spray, and you do want to control the velocity. And that depends on your own team guidelines and standards. Some might say that over 5 is a password spray. A password spray. Others will say over 100. But that's very easy to pull in whatever system you're using and just checking the velocity and the amount. Reported client type will also show you if it's an automation or somebody trying to do something manually. Exfiltration, which was also the core within the Snowflake campaign, you need query history. Out of that, you need to pull both query text and have either type of a regex or other matching of copy into, and then fitting the part you're trying to discover. And outbound data transferred cloud helps you with the built-in functionalities. Because they have the copy into functionality within Snowflake, in a single line, you can exfiltrate everything to either Azure, AWS, GCP, even web-based storage. And having that detection is usually very common. And part of those logs, you can set also the size. If you have routine backups that you know when and which size they usually are, helps reduce those false positives. And then masking policy modification. Snowflake have a built-in option where it sees sensitive data, like passwords, API keys, either PII, it auto-masks it. We know it from other log sources and other platforms. Everybody's kind of doing that. Something attackers can do, and that's very useful for the offensive people in here, is change that policy and say, all right, don't mask anything. If they keep passwords, I want them in clear text. I want to get API keys. I want to get everything juicy. Seeing that change happening is very interesting also for an insider threat scenario where one of the IT guys or the database administrators are preparing the stage for something else they're going to do. For this case, again, pulling query history, pulling query type column from that, and checking if they're either dropping the masking policy or making changes to the masking policy. And last, to be completely honest, I don't think Snowflake are the problem. We're seeing a lot of different campaigns. Recently, there was something published about Salesforce by Mandiant and Google that Salesforce are being targeted with a specific attack. The problem, in my opinion, is the approach of SaaS providers. They only do what they are forced to do. They are only developing the content they have to develop. And we need to enforce them do better. We already have a lot of good baselines and security practices for on-prem, for a lot of different technology, even for cloud. But when it comes to SaaS, everybody is just sort of ignoring it until something happens. And when defenders are coming in to investigate, they don't even have logs to look into. And when they're trying to find out where those logs are, they find they don't have them unless the company will pay for them, and there is no history. So everything starts from scratch. And attackers already know it. That's the reason they're targeting more and more SaaS platforms, because the initial access doesn't change. Simply, you log in. You either seal a session. Even if you have a phishing, you already get the SSO, which is the keys to the kingdom, where you get access to everything. And it's very, very easy. And from detection perspective, on-prem is very good detecting tools. Hashes, IOCs, a lot of those types of things. But we don't have it within cloud. Even a lot of the tools in cloud are fancy automations of SDKs and CLI commands. If you look at the top cloud red teaming tools, in the end of the day, they're using built-in functionality of either an SDK or CLI client for those platforms, and everything is just automated in a specific order. Everybody that just want to change the user agent will put a different one, and you're done. You can't really sign those types of tools. So we have to go full behavior, full baseline, and a quote-unquote, a functional UEBA for our days. So you're probably asking yourself what Snowflake did about it. So when everything happened, they brought in Mandiant as the IR provider. They reached out to their clients, and they did their own thing. As part of product changes, now they are enforcing MFA on all of the accounts unless you have SSO configured, and then it's up to the customer. And a very interesting quote about their CISO that was published very recently is, and I'm quoting from what he said, we've really pivoted from a shared security model to a more of a shared destiny model with our customers. I don't know what it means, a shared destiny. Destiny can be either good or bad, but it does show they took this campaign and impact very seriously. He also mentioned that when one of their clients is getting breached, it's a bad thing both for the client and from them as a company, and that's something I truly agree with. So I think they're trying to do more, they're trying to do better, but there are still one SaaS in an ocean of probably hundreds of thousands different SaaS platforms. And that's pretty much it. If anybody have any questions or comments.